Okay. Hi, everybody. I'm going to talk about data sharing and cross-app communication UWP. UWP is the platform that was created together with Windows 10. UWP apps run both on desktop, tablet, phones, IoT devices, Xbox, HoloLens in the future. So let me first introduce myself. My name is Pieter Nijs. I work as a senior .NET software engineer at Ordina Belgium. I'm also leader of the Mobile Competence Center at Ordina, and I'm an ALM consultant. Since short, I'm also a Meet member. Meet stands for Microsoft Extended Expert Team. You can find me on Twitter or take a look at my blog. Or if you have any questions after this talk or in general, no private issues, you can contact me via email. I did not graduate here. I thought it was important to highlight that. Currently, I'm actively working on a UWP project at our customer Telenet. So I'm working on UWP projects on a daily basis. First, does anyone have any experience with UWP? Wow. Okay. I'd also would like to thank Mobile for having me here tonight. Thank you guys, it's an honor. This is the agenda of my session. I'm going to talk about share contracts, protocol. I intended to also talk about drag and drop between Windows apps, but I have to skip it because I only got 30 minutes or so. I'm also going to talk about app services. And in the end, there's maybe some room for some questions. So let's start with share contracts. Share contracts is actually something that was invented in the Windows 8 days with our Metro style or modern style apps. You had this share charm, my god, on the right side of your screen where you got this share button, and that share button would trigger an event on your app, and so then you could give some content you would like the user to share. It's something that still exists now in Windows 10. It's a little bit, it feels a bit deprecated, but it's still there, and it's maybe the easiest way to share simple data to another app. So in share contracts, when we talk about share contracts, we have two sides of the story. You've got a source app, which is the app that will share the content, and you have a target app, which is the app that will receive the content. And for the rest of my talk, I'm going to use this terminology also when I'm going to illustrate the other mechanisms for sharing data. So how does this work? Sharing content. So we got our source app, and it's going to trigger an event to Windows. It's going to say to Windows, hey Windows, I want to share some stuff to another app. And Windows will provide me some vehicle that I can use. I can fill this box up with data and send it back to Windows. Then Windows will provide the user a share pane. It's going to say to the user, okay, this app wants to share some text data or some images or whatever. Please choose an app where you want to send this data to. The user picks a target app, and then Windows ships the data to the chosen target app. What can we share with this mechanism? Well, yeah, all kind of stuff. Plain text, links, images, storage items, HTML. So the most of your things you would like to share. So high level, the steps that you need to do is you're going to handle the data requested event of the data transfer manager. In your app, you're going to call then the data transfer manager share UI. This will go out to Windows and tell, okay, Windows, this user wants to share something. Which then also triggers the event that we subscribed to, and then we get our objects that we can use in order to ship data. The target app, so that's the other side of the story. When you want to build an app that you want it to be a shared target app, then you will first need to tell Windows, okay, this app here, it's a shared target, and you must define this declaration in the Epix manifest, and also specify the data format that it supports. In the app.saml.cs, which is almost like the app delegate in iOS, it's actually the entry point of your app. You then can override a onShare target activated method, which gets a parameter where all the data is in that the user wants to share. Once you've got this, you can redirect the user to a particular page, and on this page you can override the onNavigated_to method. You get all the data and you can do everything you want with that data. You also have to provide some feedback to the source app and to the OS, and you've got some methods for that, like data received, report completed, or report error. So let's take a look at the code. Okay. Share contract. So I'm just going to show my demos as a Windows 10 app. These apps also run on mobile clients, but it's much more convenient to see on a large screen when I show it in Windows 10. So a very simple share contract app. What I do here is very simple. As I've said, as I showed in the previous slide, I am going to register an event handler on the data requested event. I've got this button on the screen. When the user taps on that button, I'm going to say to DOS, okay, show that particular share UI. And next, this method will be called, and in these arguments, I have this request.data property, and this data property is actually our box where we can put data in. I've got some methods on it, like setText. I've also got methods setBitmap, setHTML, so that that it's clear which type of data is being sent. I'm going to show you how it works. Come on. Okay, so this is our app. I've got my share button. So when I click on it, I tell the OS, okay, show me that ugly share UI. So here we have it, and then the user can pick as I want to share text in this case. I've got all sorts of target apps that can handle text input. I'm gonna use OneNote, and this is the text that I've set in my data package. Another example, I'll show you it in a minute. The example I'm going to show you is sharing a photo, so I can also share photos. It works exactly the same, but in this case I call the setBitmap method, and I provided a reference to a photo that I've created. But I'm also going to show you how I've implemented a custom shared target app. As I've said, the first thing we need to do is we need to declare it in our manifest, and I've added the shared target declaration, and I've specified that this shared target handles bitmap data. In the app.saml.cs, I can then override the onShare target activated method. Here in these arguments are actually all the data that are being sent. I navigate to my main page, passing in these arguments. And then on the navigated to, I do some things like reading the data out of the parameter that I've got. I'm going to read the bitmap. I'm going to display the bitmap on the screen. And I'm also going to notify the OS and the source app that I've got all the data that I need. You'll see in the demo that there's also a button called upload or whatever. I don't know how I've called it. When the user taps on that one, then I'm just going to notify the OS and the source app that the sharing operation is complete. So the shared target app will close. Let me show you how it works. So the photo shared target is already installed on my machine. I'm now going to run the source app. Let's take a look. Yeah. So I'm gonna take a photo. Voila, photo. Voila. And now I'm going to tap the share photo button. And now I've got an entire different list than I've got earlier. So these are only the apps that support sharing photos. When I select the photo share target app, my custom, ooh, those demo gods, damn. No, not working here. That's a shame. But I can send it to another app. For example, I'm gonna send it to OneNote. And so OneNote handles the incoming bitmap, the extra metadata that I've set in the package. When I tap send, I don't know what's gonna happen. Then the report completed method will be triggered, and so the OS closes the shared target app. So let's move on to protocol. Protocol is a, oh, that's too sweet. Protocol is a, it already existed in Windows 8 already, but now with UWP and Windows 10, they did some improvements to it, so we got some extra things we can do. So with this protocol, let me illustrate. I can do two kind of things. I can do deep linking via a protocol, or I can launch an app in order to get a result back. So just to give you a little bit context about the deep linking story. So for example, if you have a travel app and you're on the page of, let's say for example, Barcelona, and you click on a button to see what the weather is like, a protocol could be launched to like a weather app, passing in a unique identifier for Barcelona, and that weather app will pop up and show the details of Barcelona. So to illustrate it, so I sent a package to a target app, and then the target app will open on the data that I've requested. The other example, launching an app to get a result back. For example, let's say that the target app is a calculator app or whatever that can do some very advanced calculations, and you don't want to implement it yourself in your own source app. Then you can send a message to the target app and say, okay, calculate this formula for me. Then the target app will send the result back to the source app. A little animation, and it will send the result back. So what do we need to do for this? So again, you'll see these things coming back. The target app will need to tell the OS that it is capable of being activated through protocol. And so we need to add the protocol declaration in the Apex manifest. And we also have to define a name for our protocol. In the app.saml.cs, we can override the onActivated method. and check if the activated event args, its kind property, if it is protocol. It can be all kind of stuff, but now we are interested in protocol. And then we can navigate to a particular page, passing in those activated event args which contain all the information. On the page where we navigate to, override the onNavigated_to method, read the data that we received and do something with it. So the source app, it's much more simple. We have this class called the launcher. With the launcher, we can pass in a URI, and this URI can then be of the type of our protocol that we've defined in our target app. We have different kinds of ways to send data to it, being it in a query string format or via a value set. And we'll see that that value set will come back later on. Value set is just a key value kind of list. And with this value set, it's also possible to, for example, send files along. You're not going to send the whole file through the value set, but you can create a token, send it in the value set, and then the target app can access the file through the given token. If we want to activate our app in order to get a result back, we can call the launch URI for results async method on our static launcher class. And also same story here. We can send data through the through a query string or through a value set. Yeah, okay. So this method returns a launch URI result, which contains a status, which indicates if the call was successful or not, and it also returns a result, which is again a value set. Come on, I click. Okay, perfect. In the target app, again the same story. Declare it that it can be activated through protocol. The only difference is now that on the onActivated method in our app.saml.cs, that we can check on the protocol for results activation. And then again, we can navigate to a particular page. On that page, we can do stuff with the data and report our result in a value set back using the report completed method. So let's go back to code. We've got a protocol launcher project, which is just a bunch of buttons that will launch different URIs. So I've got here my protocol, my app.showData, whatever. I have got a button that sends data to the target app with a query string. And I've also got a launcher that sends data to the target app using a value set. Now, if you take a look here, when we provide a value set, we also have to provide extra launcher options. And with these launcher options, I can indicate that I want to target a particular app. So there might be multiple apps which can react on the myApp.showData protocol. But when I pass in a value set, I have to clearly identify which app I want to launch. It's probably security reasons or something. So I have to provide it with once I send a value set with it. I've also got a button in my demo app that sends input data to the target app, and it expects a result back from the target app. Once I've got this result, I can read the actual result from the result property, which is a value set. And in this case, I'm going to show the result in a dialog. This protocol app, so this is the app that's going to be activated. I've added a declaration of type protocol. I've given it a name, so this matches exactly the protocol I used in my launcher app. And in my app.saml.cs, on the onActivated method, I'm going to check, okay, if it is a protocol, I send the user to this particular page, passing in my arguments. If it's a protocol for results request, I send the user to a other page. On the page without results, I'm just going to output the data that I've received, so nothing fancy here. And in the protocol for results page, I'm not going to show anything. I'm just going to read my input data as a string. Gonna call a toUpper method on it and provide that result back to the source app. So let's run this protocol launcher. That's fast. That's new. So when I call it with no data, my target app just gets activated. I didn't specify any extra data, and I just output the protocol that was used to activate this app. With the query string, you see the following. I read the query string, and I also get this data. With a value set, same thing. I just show the protocol through which it was activated. I read the value set, I print it out, and then for result, you see the app, the target app launch quickly, do its stuff, and then close again. It does put my text in uppercase, and I show it here in this message dialog. Okay. To close my talk with app services, as you've seen in the last scenario that I have shown you, when I ask a result from another app through a protocol, that app really launches. It launches, it does its stuff, then it closes. With an app service, you can do the same thing. Haha, haha. This is ridiculous. We can do the same thing. Yeah. Okay. But without another UI or another app popping up. So how can we do this? We can, if we build an app, we can package a background task with it, an app service. And every other app can communicate with that background service without invoking the mother app, or how should I call it. This ensures that the user stays in his in the current app and is not redirected to another app. So what do we have to do for this? The main app containing the actual service, the background task, it also needs again a declaration, the Epix manifest of type app service. We need to provide it a name and point to the starting point of the service itself. The service itself, it's another type of project. It's a Windows runtime component, and in there we need to create a class that implements the iBackground task interface and implement the run method. So, and the name of this class and its namespace must exactly match the entry point that I've created in the manifest of the containing app. Oh, come on, dat meen je nu toch niet. Okay. The source app, so this is the app that is going to communicate with my service. Very easy. It needs to make a connection to that background service by providing a service name and a package family name. Must open a connection, send some data back and forward, and do something with it. Short demo. Visual Studio, app services. So I've got my, no, again, not, I've never had these issues before, come on. Okay. Close this fucker, okay. It's recorded, right? Sorry. Okay, so this app services app is actually the app containing a separate background service. And in the manifest, I've declared a services declaration, app service declaration. I've given it a name and I've given it a entry point. And so this entry point points to this app service, which is an implementation of the iBackground task. And this run method will be invoked once a source app made a connection to that background service. I here also wire up an or hook up an event handler for the request received. So once the source app then sends a message to the service, then we come into this method. We can read the data, which is again a value set, of course, and we can do all kinds of stuff with it. And in the end, I can just say, okay, send response back to the source app, which is again a value set. How do I call this service? Easy. I make a new app service connection instance. I provide the name to the service I want to talk to. I also need to provide a package family name. Open the connection. So this is when the run method is triggered on the service. I can send a message. I can wait for a result, and once I have a result, I can check if it was okay or not. Then I can read the status from it. Let me show you this quickly. So in this example, I pass in two values in the value set, a command, which has the value to lower, and an input value, which is a text. Fingers crossed. Okay, so I'm going to click the button. It will make the connection to the app service, and the app service will send me back some data. Voila, this is the result. So my text is now in lowercase, so this is a big lie on the screen. And this is without invoking the other app. The other app wasn't opened. I'm just talking to the underlying service. So I've talked about these value sets a lot, and that's actually the vehicle that passes data from a source app to another to a target app, and from a target app back to the source app. It is just key value pairs, and it's a bit of a pain in the so and it's very error prone. You could easily make a typo or pass in wrong data. A solution I thought of was, if you create an app and you would like other apps to connect to your app, also make some kind of library. I think Siba also mentioned it, to do it with Android, that you make a library that other developers can use to strongly type access your application. And in the .NET world, we can easily distribute it via NuGet in a NuGet package. And this is maybe a thing that you could do or think about when you build an app that allows communication from another app. I'm gonna make a blog post about it one of the next weeks or months when I've got some time left. But keep an eye on my blog. So that was everything I wanted to say. Are there any questions? other than why my PC didn't work as expected. Yeah.
With the share contract,
Yes.
is it possible to extend the functionality of the data class to add your own file extensions or data?
So the question is if in the context of share contracts, or if you can extend with other extensions, right? No, it's not possible. You're limited to text, bitmap, HTML, these things. So PDF is not possible. No. Any other? Yes.
So it's since it is UWP, it works on all devices.
Yeah.
Is there anything provided that you can share or do interprocess across different devices? So if you have a phone, call your tablet or call your Windows machine, or
Okay. So the
is it
question.
always local, or can it be more remote than
Yeah.
just a local machine?
The question is if these shared techniques can go across machines instead of keeping it local. I'm afraid you have to keep it local. If you want to share it with another machine, you'll have to use web services or whatever, or other protocols. Yes.
In the last code example you gave, is the communication synchronous or asynchronous? Because I saw you
Okay.
make the request and handle the response in the same method. So
Okay. So the question is, in the last example, when I sent data to the service where I get data back, the question is this asynchronous? Yes, it is asynchronous, and you're probably not a .NET developer, because we have this really nice thing called, where is it? Async await. So this is actually an async method, and instead of doing all these weird wirings or error-prone logic, I can just say here await. The UI thread will again get processing time, whatever, until the async process is done. So +1 for .NET. Yes.
The protocol and the app service, which one is the best?
So the question is, which one is the best, protocol or the app service? Well, it depends. I think they both have their benefits and their their weaknesses. I don't know. It depends. With protocol, you always have the other app, the target app, being activated. So that's maybe not that good user experience. If the other app supports app services, might be better to talk via app services, so that the user stays in his app.
No, it's a question.
Okay. Okay. So thank you for your attention. I hope it it was interesting. Thank you.